In this lesson, we are going to solve problems that involve rates. Paula is asked to order snacks for an office meeting of 180 people. She decides to order dessert squares, which come in boxes of 24. She estimates that she will need 2.5 squares per person. How many boxes should she buy? Now, I should be clear that there is more than one way to get the correct answer here. So if you know of another way and it makes sense to you and it's something that will work every time, feel free to use it. One of the ways we can look at is she's got 180 people coming and she needs 2.5 squares per person. So we need to find out how many squares she's going to need altogether. So she's going to need 450 squares. Now these come in boxes of 24, so she should find out how many boxes she needs. And we get 18.75. Now we can't buy part of a box. So you have to think, should she buy 18 or should she buy 19? If she only buys 18 boxes, she may not have enough. So she should buy 19 boxes just to be on the safe side. Amy walks briskly at 6 kilometers per hour. When she walks at this rate for 2 hours, she burns 454 calories. Bruce walks at a slower rate, 4 kilometers per hour, and burns 62 calories in 30 minutes. If Amy walks for 3 hours, how much longer will Bruce have to walk in order to burn the same amount of calories? Well, first what we need to find out is we need to find out how many calories Amy burns in 3 hours. What we do know is that she burns 454 calories in 2 hours. So how many calories will she burn in 3 hours? So we set this up as a proportion and we can do cross multiplication. And again, there's more than one way to do this. Now we can divide by 2. So she burns 681 calories in 3 hours. Because that is what we were looking for. We were looking for how many she would burn in 3 hours. So 681 calories. So now we have to see how long it's going to take Bruce to burn the same amount of calories. What we know is that Bruce burns 62 calories in 30 minutes. Now, what we have to do is we either have to consider this in minutes or hours. So it's up to you on which you wish to use. So if we change that to 0.5 hours, what we want to now determine is how long is it going to take in hours, because we changed it to hours, for him to burn 681 calories. So now we can do a cross multiplication. 681 times 0.5 is 340.5 equals 62x. Divide both sides by 62, and it's going to take him approximately 5.5 hours, because that is what we were looking for. We were looking for how many hours. So if he walked for 5.5 hours at his rate, he would burn 681 calories. We want to describe a situation in which each rate might be used. So if we look at the first one, we're talking about milligrams per kilogram. This one is a little bit tricky unless you are familiar with certain situations. But a certain situation where they would use milligrams per kilogram is in putting together certain medications. Maybe they need 0.05 milligrams of the medication per kilogram of mass of a person's body. So that is one place where they may use this kind of a unit. B should be a little bit more familiar. 98.5 cents per liter. What about the price of gas? It wasn't that too long ago. It is a little bit more now, but that might be a way that they sell gasoline. You pay 98.5 cents per liter of gas. And the last one, that's called megabytes per second. And that might be how quickly things transfer or go through your computer. Computers do have this sort of a rate to them. Jeff lives in a town near the Canada-US border. The gas tank of his truck holds about 90 liters. He can either buy gas in his town at $1.06 per liter or travel across the border into the United States to fill up at $2.86 US per gallon. 1 US gallon is equivalent to 3.79 liters, and on the day Jeff needs to fill up, the exchange rate is $1 US is $1.02 Canadian. Now, yes, I know there are other situation and factors to determine. How far does he have to go? How much gas does he actually use? Let's just keep it at a very basic conversion right now. And let's find out what it would cost him to fill it up in Canada and what it would cost him to fill it up in the States. So let's start with how much it would cost to fill up in Canada. Well, he's got to fill 90 liters and it costs $1.06 per liter. So we multiply those together, and in Canada it is going to cost him $95.40 Canadian. Now let's determine how much it's going to cost him to fill up in the States. The first thing we need to determine, and again there's more than one way to do this conversion and to do this problem, but let's look at finding out how many gallons he's going to actually need. He has 90 liters. What we know is that 1 US gallon is equivalent to 3.79 liters. So 1 gallon is 3.79 liters. His truck holds 90 liters. So we need to find out how many gallons that would be. So we do the multiplication. We're going to have 3.79x equals 90. Divide 90 by 3.79. He is going to need 23.7 gallons. So now we can determine 23.79 or 23.7 gallons at $2.86 per gallon. It is going to cost him $67.78 US because it was $2.86 US. So now what we have to do is we have to convert to the same money. So if we want to convert this back to Canadian, we know that 1 US dollar is equal to $1.02 Canadian. That comes from right here. He has $67.78 US. How many Canadian dollars is that? We're multiplying those values together. It is going to cost him $69.14 Canadian if he goes into the States. So if you look at the difference here, $25 approximately cheaper for him to cross into the States. So then you could consider if he's really only a 5-minute drive and he's barely going to use any gas, it's probably not a bad deal to drive into the States. If it's an hour round trip and it's going to cost him a good chunk of gas, maybe it's not worth it. But if all things are considered fairly equal, it would be cheaper to go to the US to buy his gas. So when you are given a rate problem that involves an unknown, you can solve the problem using a variety of strategies. So I just showed you one strategy for each one, but there are other strategies that you can use. Often a problem that involves a rate can be solved by writing an equation that involves a pair of equivalent ratios. So we were using proportions for a lot of these. To be equivalent ratios, the units in the numerators of the two ratios must be the same, and the units in the denominators must be the same. Paying attention to the units in each term of the ratio will help you write the equation correctly. So what that means is if we go back here, we kept gallons in the numerator and we kept liters in the denominator. Now, technically, it wouldn't really matter if we had put the liters in the numerator and the gallons in the denominator, as long as we stay consistent. A multiplication strategy can be used to solve many rate problems, such as problems that require conversions between units. Including the units with each term in the product and using unit elimination helps you verify that your product is correct. And when a rate of change is constant, writing a linear function to represent the situation may be useful when solving problems. So just some things to think about.